All right, so welcome to day two. We are burning through kind of the content. We've made it through a lot of content, a lot of definitions yesterday. Not a whole lot of application, mostly just definitions and some simple concepts. We're going to get to a little bit of application towards the end of today, but there's still more definitions to go through just to kind of understand some of the content. Find a place to store my video here. Alright, so we're going to look at operators today, floating point accuracy, typecasting, and input-output console operations. Again, this is straight from the syllabus for the PCEP exam. This is what they want us to cover to make sure that you're prepared for the exam. So that's what we're going to do. Most of this stuff is pretty straightforward, more or less, but a lot of it's used, right? So yesterday was just a lot of terminology, and a lot of it wasn't necessarily used. You didn't know it to be able to write the code. Today, certainly when we get to the Boolean expressions, all the operators, these are things that you're actually putting in the code. So understanding what they are and what they do matters a little bit. Certainly the print and input functions are the way that you interact with the machine or have the machine interact with the user. And int and float functions, these are more of the typecasting here, just the idea of how to manipulate some of the data. So this is something that Python's really pretty good at, and it's used a lot for just manipulating data and organizing data. So without that, let's just jump down. We're going to start on the operators. So like I said before, these are things that actually happen in the code. They form some sort of computation. Some of them are going to be really familiar with. It's just kind of basic arithmetic. But other ones are substitutes for the arithmetic that we know, but we can't necessarily input them into a keyboard. And we'll talk about a little bit about what that is. But we're going to start with the operators. So there are numeric operators. And again, like I said, some of them we're really familiar with, right? The idea of addition, subtraction, multiplication, division. These are things that we just know. Right? These are things that we know that the plus sign is addition, the minus sign is subtraction. Most people are familiar with the idea that the asterisk is a multiplication and that the slash is division. Some people maybe not, but I think we're probably all really familiar with the idea of using these as representations, just because we've been around computers for a long time, so we should know that these, even have calculators, these represent basic arithmetic. So this is a dual asterisk here, and it represents exponents. We can write exponents with the 2 caret 3, right? And that means 2 to the third. This is something that we would normally write it as. If we were writing it on paper, the 3 would be smaller than the 2. Writing it on just in text on the computer is 2 caret 3, and we know that means 2 to the third. But in Python, the notation is just 2 asterisk 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 3. It's actually harder to say than it is to type and remember. All you need to know is that anytime you need an exponent, you just put asterisk asterisk. That's it. This one, the percentage, is called a modulus. This is something that people have had trouble with in some of the other classes that I teach, and it's probably my fault because I don't explain it very well. But the idea is that it represents the remainder. So it's effectively saying 17 divided by 4, and then how much is left. So 4 will go into 17 exactly 4 times. Well, not exactly. We'll go into 17 4 times, but that means that it's 16. So 17 minus 16 is 1, and that's where you get the remainder. The 1 is how much value is left after you divide the number into the other. Right, so 17 divided by 4 is technically 4 1/4. So you know that 4 is the highest value, and then you have to figure out how many are left. 4 times 4 is 16. 17 minus 16 is 1. You can do it with other numbers. You can say like 9 modulus 2. 9 modulus 2, 2 will go into 9 4 times. 2 times 4 is 8. 9 minus 8 is 1. Usually, modulus is a really good way to figure out if a number is odd or even. Now, we know when we look at a number if it's odd or even, but the computer doesn't necessarily give it that designation. So if you do the number modulus 2 and it comes up with a 0, that means that it's an even number. If it comes up with a 1, that means it's an odd number. So 8 divided by 2 is 4. 4 times 2 is 8, so 8 minus 8 is 0. You know that it's an even number. 17 modulus 4 is an odd number because there's one value left. And when you're using modulus 2, it's always going to be a 1 or a 2 because there can only be one value left. If there's two values left, then you just increase the number that it's divisible by, right? So 10 would be equal to 5, 5 times 2. 12 is 6 times 2, and those are even. They equal the even number. They leave you with 0 remainder, so you know it's even. If you're doing a modulus 3, then your remainder can either be a 1 or a 2. Modulus 4, it could be a 1, 2, or 3, so forth and so on. But the modulus is how much value is left after you do the division. The next term I want to talk about is floor division. And this is similar to modulus, right? It works with the same idea, but it gives you the different result. So 17 divided by 4, what it does is it gives you the highest integer less than or equal to the result. So 17 divided by 4, we know is 4.25. But 4, that means, is the largest integer value less than or equal to the result. Right? So the floor basically what it's doing is it's converting your division into an integer, and it's just deleting anything that would come after the decimal. So that's what floor division does. Now, single division in Python, if you just do 17/4, that's always going to give you 4.25. The single division in Python always returns a float. And we talked about floats and integers in the last presentation. But the single division always returns a float. If you use the double division or the floor division, it's always going to give you an integer. And that's the difference between them. We'll look later at the idea of converting a float to an integer. You could do that as well if you needed it, but it's an extra step. And generally, anytime you do an extra step, it's a slower calculation for the computer. This is more efficient, but for most of what we're going to be doing, or anyone would be doing, you could just convert it. But this gives you an integer value. So then we have string operators. Now, we already talked about, we know that an asterisk is multiplication. But you can't do math with words, right? So hello times 3 it returns hello, 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 right? So you're getting 3 hellos. That's what the asterisk does in a string operation. We call it repetition. It's multiplication. You can't do math with words, right? But that's effectively what you're trying to do here with the repetition. Hello, hello, hello is hello times 3, or repeated 3 times. The plus sign represents concatenation. You can't, again, do math with strings, so you can't add strings, but the plus sign just connects the strings together. And that's called concatenation. It's a word. All it means is putting strings together beside one another. So you have hello plus a space plus world. When you put all of that together, it returns hello space world. You can do this with any number of strings. In this case, we've added 3 strings together. So hello is 1, the space is 1, and the world is 1. But you could add 45 strings together. This is some way that we make, we make automated email addresses. We'll take the first letter of your first name, the full last name, and then a string of numbers, whatever the numbers are, and then we add all of that to at whatever your email address is, Gmail or Stanley or JCSU, whatever your email address is. Once we have your name, we can just use a concatenation of strings to build your email address or your student login, whatever it is. That's all we're doing, and Python is pretty good at that. Most programming languages are pretty good at that. It's pretty fast. But it's an idea of just adding strings together. So then we want to talk about some shortcut operators, right? And again, this is just math. This is stuff that you're probably going to use, but you don't necessarily have to. When we talk about operators, we're talking about using a variable. So in this case, the variable is A, and assigning some value to it. So we've already seen a equals 3 is assigning the value 3 to a. Once you have a value established, right, then you can modify that value by adding numbers to it. So a is equal to a plus 3, a minus 2, a is equal to a times 4, a is equal to a divided by 2. You can do basic arithmetic with any numeric variable that you have in order to make that faster, because a lot of programming is doing just simple math along the way, right? So over time, people have decided they needed a way to make that simpler to write, because for some reason they thought that a is equal to a plus 3 takes too long to write, so they've shortened it to just a plus equal to 3. The plus equals, all it's doing is saying a is equal to a plus, right? So it's a shorter way to write a is equal to a plus, and then the number after it is the modifier. Same thing with minus equals and multiplication, asterisk equals, and divided by equals. All it is a shortcut for writing out the full statement. If you ever need to do this, you can write out the full statement. It's totally fine. But for the exam, they want you to know what the shortcut operators are, just because people use them. One thing that's different in Python compared to another language you may have known, in a lot of other languages, you could do a++, which is automatically equal to a is equal to a plus 1. Python never implemented that. So there is no plus plus in Python. It's always plus equal to 1. Or plus equal to 2, whatever it is. But the plus plus doesn't exist in Python. So just know that if you're really familiar with another language and you're writing a loop or you're writing a counter, you might want to use a++. Just know that it's probably going to spit out an error, or you're going to confuse the interpreter. All right, the next thing I want to talk about is unary operators. So this is just terminology, right? And the application of using this is much simpler than the terminology. Finding a way to explain this was kind of tough. The idea is that there's only one operator. It could be a plus, a minus, an exclamation point, or a tilde. But the minus just represents the idea that the unary operator is a negative number. So this is taking the value 5 and making it negative. This is taking the value true and making it not true. So the exclamation, in most every instance, when you see the exclamation in Python, it means not. And it's used a lot in Boolean operators. You have a true statement, it means not true. You have a false statement, it means not false. But you can use it in other instances as well. If you were trying to compare two values and you just wanted to make sure they were not equal to, you could just do not equal. And it's a unary operator because it's just one operator in front of the value that you're working with. So again, it's a lot of words, right? But all it means is that there's just one operator in front of the value you're working with. Unary. There may be another way to pronounce that. That's how I pronounce it. I'm at about 13.5 minutes. I'm going to go ahead and pause the video, save it. We'll start the next video on the next slide. And I think today we might have 3 slides or 3 videos, and then we'll have a 4th video looking at Python online, just to get some actual coding in, because we haven't done that yet. There's a lot of terminology. With any exam, there's a lot of terminology, and I'm just going through step by step to make sure we understand all the terms before we get to the programming. So that's where we are right now, but I'm going to pause it, and we'll see you in the next video.